Central Processing Unit, or CPU, is the hardware within a computer that carries out the instructions of a computer program by performing the basic arithmetical, logical, control, and input or output operations of the system. The term has been in use in the computer industry at least since the early 1960s. The form, design, and implementation of CPUs have changed over the course of their history, but their fundamental operation remains much the same. Two typical components of a CPU are the arithmetic logic unit, or ALU, which performs arithmetic and logical operations, and the control unit, or CU, which extracts instructions from memory and decodes and executes them, calling on the ALU when necessary. Another input device is a computer keyboard. A computer keyboard is a typewriter-style device which uses an arrangement of buttons or keys to act as a mechanical levers or electronic switches. Following the decline of punch cards and paper tape, interaction via teleprinter-style keyboards became the main input device for computers. A keyboard typically has characters engraved or printed on the keys, and each press of a key typically corresponds to a single written symbol. However, to produce some symbols requires pressing and holding several keys simultaneously or in sequence. While most keyboards keys produce letters, numbers or signs or characters, other keys or simultaneous key presses can produce actions or execute computer commands. Despite the development of alternative input devices such as the mouse, touchscreen, pen devices, character recognition, and voice recognition, the keyboard remains the most commonly used device for direct human input of alphanumeric data into computers. Another example of an output device is a computer monitor. A monitor or a display is an electronic visual display for computers. The monitor comprises the display device, circuitry, and an enclosure. The display device in modern monitors is typically a thin film transistor liquid crystal display, or TFT LCD thin panel, while older monitors use a cathode ray tube, or CRT, about as deep as a screen size. Originally, computer monitors were used for data processing, while television receivers were used for entertainment. From the 1980s onwards, computers and their monitors have been used for both data processing and entertainment, while televisions have implemented some computer functionality. The common aspect ratio of televisions and then computer monitors has also changed from 4:3 to 16:9 and 16:10. A mouse is an input device. In computing, a mouse is a pointing device that detects two-dimensional motion relative to a surface. This motion is typically translated into the motion of a pointer or on a display, which allows for fine control of a graphical user interface. Physically, a mouse consists of an object held in one's hand with one or more buttons. Mice often also feature other elements, such as touch surfaces and wheels, which enable additional control and dimensional input. A printer is an output device. It is a peripheral which makes a persistent human-readable representation of graphics or text on paper or similar physical media. The two most common printer mechanisms are black and white laser printers used for common documents and color ink jet printers which can produce high-quality photograph quality output. A computer is also comprised of output devices. An example of these is a computer speaker or multimedia speakers. These speakers are external to a computer that disable the lower fidelity built-in speaker. They often have a low-power internal amplifier. The standard audio connection is a 3.5 mm, approximately 1/8-inch stereophone connector, often color-coded lime green, following the PC99 standard for computer sound cards. A few use a RCA connector for input. There are also USB speakers, which are powered from the 5 volts at 500 milliamps provided by the USB port, allowing about 2.5 watts of output power. Computer speakers were introduced by Altec Lansing in 1990. Computer speakers range widely in quality and in price. The computer speakers typically packaged with computer systems are small, plastic, and have mediocre sound quality. Some computer speakers have equalization features such as bass and treble controls.
Go. Hi, I'm Katrina and I will be telling you about the history of computers, like how it was started and who invented it. So let us all explore the history of computers.
The history of computers. The first computers were people, that is, electronic computers, and the earlier mechanical computers were given this name because they performed the work that had previously been assigned to people. Computer was originally a job title. It was used to describe those human beings, predominantly women, whose job it was to perform the repetitive calculations required to compute such things as navigational tables, tide charts, and planetary positions for astronomical almanacs. Imagine you had a job where hour after hour, day after day, you were to do nothing but compute multiplications. Boredom would quickly set in, leading to carelessness, leading to mistakes. And even on your best days, you wouldn't be producing answers very fast. Therefore, inventors have been searching for hundreds of years for a way to mechanize, that is, find a mechanism that can perform this task. The abacus was an early aid for mathematical computations. Its only value is that it aids the memory of the human performing the calculation. A skilled abacus operator can work on addition and subtraction problems at the speed of a person equipped with a hand calculator. The abacus is often wrongly attributed to China. In fact, the oldest surviving abacus was used in 300 BC by the Babylonians. The abacus is still in use today, principally in the Far East. A modern abacus consists of rings that slide over rods, but the older one pictured below from the time when pebbles were used for counting. In 1617, an eccentric Scotsman named John Napier invented logarithms, which are a technology that allows multiplication to be performed via addition. The magic ingredient is the logarithm of each operand, which was originally obtained from a printed table. But Napier also invented an alternative to tables, where the logarithm values were carved on ivory sticks, which are now called Napier's bones. Napier's invention led directly to a slide rule, first built on England in 1632 and still in use in the 1960s by the NASA engineers of the Mercury, Gemini, and Apollo programs, which landed men on the moon. Leonardo da Vinci made drawings of gear-driven calculating machines but apparently never built any. The first gear-driven calculating machine to actually be built was probably the calculating clock, so named by its inventor, the German professor Wilhelm Schickard in 1623. This device got little publicity because Schickard died soon afterward in the bubonic plague. In 1642, Blaise Pascal, at age 19, invented the Pascaline as an aid for his father, who was a tax collector. Pascal built 50 of these gear-driven one-function calculator but couldn't sell many because of their exorbitant cost and because they really weren't that accurate. Up until the present age, when car dashboards went digital, the odometer portion of a car's speedometer used the very same mechanism as the Pascaline to increment the next wheel after each full revolution of the prior wheel. Pascal was a child prodigy. At the age of 12, he was discovered doing his version of Euclid's 32nd proposition on the kitchen floor. Pascal went on to invent probability theory, the hydraulic press, and the syringe. Just a few years after Pascal, the German Gottfried Wilhelm Leibniz, the co-inventor with Newton of calculus, managed to build a four-function calculator that he called a stepped reckoner because, instead of gears, it employed fluted drums having 10 flutes arranged around their circumference in a stair-step fashion. Although the stepped reckoner employed the decimal number system, Leibniz was the first to advocate use of the binary number system, which is fundamental to the operation of modern computers. Leibniz is considered one of the greatest of the philosophers, but he died poor and alone. Jacquard's technology was a real boon to mill owners, but put many loom operators out of work. Angry mobs smashed Jacquard looms and once attacked Jacquard himself. History is full of examples of labor unrest following technological innovation, yet most studies show that overall, technology has actually increased the numbers of jobs. By 1822, the English mathematician Charles Babbage was proposing a steam-driven calculating machine the size of a room, which he called the difference machine. This machine would be able to compute tables of numbers such as logarithm tables. He obtained government funding for this project due to the importance of numeric tables in ocean navigation. By promoting their commercial and military navies, the British government had managed to become the Earth's greatest empire. But in that time frame, the British government was publishing a 7-volume set of navigation tables, which came with a companion volume of corrections, which showed that the set had over 1,000 numerical errors. It was hoped that Babbage's machine could eliminate errors in these types of tables. But construction of Babbage's difference engine proved exceedingly difficult, and the project soon became the most expensive government-funded project up to that point in English history. 10 years later, the device was still nowhere near complete. Acrimony abounded between all involved and funding dried up. The device was never finished. Babbage was not deterred, and by then was on to his next brainstorm, which he called the analytic engine. This device, large as a house and powered by 6 steam engines, would be more general purpose in nature because it would be programmable, which thanks to the punch card technology of Jacquard, but it was Babbage who made an important intellectual leap regarding the punch cards. In the Jacquard loom, the presence or absence of each hole in the card physically allows a colored thread to pass or stops the thread. Babbage saw that the pattern of holes could be used to represent an abstract idea such as a problem statement or the raw data required for that problem solution. Babbage saw that there was no requirement that the problem matter itself physically pass through the holes. Furthermore, Babbage realized that punched paper could be employed as a storage mechanism holding computed numbers for future reference. Because of the connection to the Jacquard loom, Babbage called the two main parts of his analytic engine, the store and the mill, as both terms are used in the weaving industry. The store was where numbers were held, and the mill was where they were woven into new results. In a modern computer, these same parts are called the memory unit and the central processing unit. The analytic engine also had a key function that distinguishes computers from calculators: the conditional statement. A conditional statement allows a program to achieve different results in each time it is run. Based on the conditional statement, the path of the program, that is, what statements are executed next, can be determined based upon a condition or situation that is detected at the very moment the program is running. You have probably observed that a modern stoplight at an intersection between a busy street and a less busy street will leave the green light on the busy street until a car approaches on the less busy street. This type of street light is controlled by a computer program that can sense the approach of cars on the less busy street. That moment when the light changes from green to red is not fixed in the program but rather varies with each traffic situation. The conditional statement in the stoplight program would be something like, if a car approaches on the less busy street and the more busy street has already enjoyed the green light for at least a minute, then move the green light to the less busy street. The conditional statement also allows the program to react to the results of its own calculations. An example would be the program that the IRS uses to detect tax fraud. This program first computes a person's tax liability and then decides whether to alert the police based upon how that person's tax payments compare to his obligations. Babbage befriended Ada Byron, the daughter of the famous poet Lord Byron. Though she was only 19, she was fascinated by Babbage's ideas, and through letters and meetings with Babbage, she learned enough about the design of the analytic engine to begin fashioning programs for the still unbuilt machine. While Babbage refused to publish his knowledge for another 30 years, Ada wrote a series of notes wherein she detailed sequences of instructions she had prepared for the analytic engine. The analytic engine remained unbuilt, but Ada earned her spot in history as the first computer programmer. Ada invented the subroutine and was the first to recognize the importance of looping. Babbage himself went on to invent the modern postal system, cow catchers on trains, and the ophthalmoscope, which is still used today to thread the eye. The next breakthrough occurred in America. The U.S. Constitution states that the census should be taken of all U.S. citizens every 10 years in order to determine the representation of the states in Congress. While the very first census of 1790 had only required 9 months, by 1880 the U.S. population had grown so much that the count for the 1880 census took 7.5 years. Automation was clearly needed for the next census. The Census Bureau offered a prize for an inventor to help with the 1890 census, and this prize was won by Herman Hollerith, who proposed and then successfully adopted Jacquard's punch cards for the purpose of computation. Hollerith's invention, known as the Hollerith desk, consisted of a card reader which sensed the holes in the cards, a gear-driven mechanism which could count, a large wall of dial indicators to display the results of the count. The patterns on Jacquard's cards were determined when a tapestry was designed and then were not changed. Today, we would call this a read-only form of information storage. Hollerith had the insight to convert punch cards to what is today called a read-write technology. While riding a train, he observed that the conductor didn't merely punch each ticket but rather punched a particular pattern of holes whose positions indicated the approximate height, weight, eye color, etc. of the ticket owner. This was done to keep anyone else from picking up a discarded ticket and claiming it was his own. Hollerith realized how useful it would be to punch new cards based upon an analysis of some other set of cards. Complicated analysis to be accomplished during a single pass through the cards could be accomplished by multiple passes through the cards using newly printed rubric. Remember, the intermediate results. Unknown to Hollerith, Babbage had proposed this long before.
There are many different types of computers in this world because technology had been increasing in the past few years. This topic will be about the different types of computer categories, from the old up until the new ones. So, sit back, relax, and listen.
Microcomputer, a small, relatively inexpensive computer with a microprocessor as its central processing unit. It is generally a synonym for the more common term personal computer or PC. Microcomputer became popular in the 1970s and 80s with the advent of the increasingly powerful microprocessors. What I have here is an example of a microcomputer, which is the Commodore 64. It is one of the most popular microcomputer of its era and is the best-selling model of home computer of all time. Next is the mini computer. It is a computer of a size in between microcomputer and the mainframe. It is a multi-processing system capable of supporting from 4 to about 200 users simultaneously. They are typically standalone computers, which are computer systems with attached terminals and other devices that are sold to small and mid-sized businesses. What I have here is an example of a mini computer, which is the Data General Nova serial number 1. The first 16-bit mini computer built by the American company Data General Starting in 1969, it became popular in science laboratories around the world, and eventually 50,000 units were sold. Next is the mainframe computer, also known as pig iron, a very large and expensive computer capable of supporting hundreds or even thousands of users simultaneously. It is a high-performance computer used for large-scale computing purposes that require greater availability and security, including bulk data processing, process control, industry and consumer statistics, enterprise resource planning, and financial transaction processing. Next, from the new category, first is personal computer. It is a general-purpose computer whose size, capabilities, and original price makes it useful for individuals like us. It is intended to be operated directly by an end user with no intervening computer operator. At home, the most popular use for personal computers is for playing games. Businesses use personal computers for word processing, accounting, desktop publishing, and for running spreadsheet and database management applications. A personal computer may be a desktop computer or a laptop, netbook, tablet, or a handheld PC. Next from the new category is the workstation, a high-performance computer system that is basically designed for a single user and has advanced graphics capabilities, large storage capacity, and a powerful microprocessor. A workstation is more capable than a personal computer, but is less advanced than a mid-range computer. In networking, workstation refers to any computer connected to a local area network. It could be a workstation or a personal computer. The third one in new category is servers, a computer or device on the network that manages network resources. It is capable of requests from client and giving responses accordingly. In the client-server programming model, a server is a program that awaits and fulfills requests from client programs in the same or other computers. A given application in a computer may function as a client with a request from services from other programs and also as a server of a request from other programs. An example of server is a data center. Several servers are mounted on a rack and connected to a KMV switch. Next are the supercomputers, the fastest type of computer, and they're very expensive and are employed for specialized applications that require immense amounts of mathematical calculations, like weather forecasting or animated graphics. The chief difference between a supercomputer and the mainframe is that a supercomputer channels all its power into executing a few programs as fast as possible, whereas a mainframe uses its power to execute many programs concurrently. The Tianhe-2, a supercomputer developed by China's National University of Defense Technology, is the world's #1 system with a performance of 33.86 petaflops or quadrillion of calculations per second on the LINPACK benchmark. It was built by China's National University of Defense Technology in collaboration with the Chinese IT firm Inspur. According to NUDT, Tianhe-2 will be used for simulation, analysis, and government security application. It is now located at Guangzhou, China, and it is cost about 2.4 billion yuan or 390 million US dollars. Amazing, so expensive. So that's the Tianhe 2, which or Milky Way 2, or in my term, the Great Wall of Computer. Next is the video game console for the gamers, a machine designed for consumers to use for playing video games on a separate television where video and sounds are received by the gamer. The player interacts with the game through a controller, a handheld device with the buttons and joysticks or pads. An example of consoles will be Microsoft Xbox, Sony PlayStation, Nintendo GameCube, and Nintendo Wii. Wow, how I wish I have those consoles in my house. So, moving on, the last but not the least are handheld computers. These are portable computers that are small enough to be held in one's hand. Although extremely convenient to carry, handheld computers have not replaced notebook computers because of the fact that they have a small, teeny tiny keyboards and screens.
Elements of a computer system. Basically, there are three elements of a computer system, namely hardware, software, and peopleware. Hardware is the physical element of a computer system, while software is the logical element in a computer system. It is also known as the program, while are the users of the program like us. For based on our research, there is an additional element of a computer system, which is dataware. We'll try to find out more about these elements on our discussion.
Primary components of a computer: input devices, central processing unit, memory, output devices, and storage devices. Let us discuss each of these components. Under input devices are the keyboard and the mouse. The keyboard is where the data is entered by manually typing certain keys. A keyboard typically has 101 or 105 keys. Next is the mouse. It is a pointing device which is used to control the movement of a mouse pointer on the screen to make selections from the screen. The next component is the central processing unit, or the CPU. It contains electronic circuits that cause processing to occur. It interprets instructions to the computer, performs the logical and arithmetic processing operations, and causes the input and output operations to occur. It is considered the brain of the computer. Next component is the memory. Under memory are the two types, the RAM and the ROM. RAM, which is the random access memory or temporary memory, is the main memory of the computer. It consists of electronic components that store data including numbers, letters of the alphabet, graphics, and sound. Any information stored in RAM is lost when the computer is turned off. Next is the ROM, or the read-only memory. It is a memory that is etched on a chip that has start-up directions for your computer. It is a permanent memory. Next component is the output devices. Under output devices are the printer and the computer screen. The printer produces a hard copy of your output, and the computer screen produces a soft copy of your output. Next component is the storage devices. It is where to store data when they are not being used in memory. The most common types of auxiliary storage used on personal computers are floppy disk drives, hard disk, and CD-ROM drives. The next element of a computer system is the software. There are two kinds of software, namely system software and application software. Under system software are the operating system, programming tools and IDE, loaders, compilers, assemblers, and linkers, device drivers, and utilities. Under application software are the word processors, electronic spreadsheet, presentation, media development, and database. Peopleware is the user of the computer system.
All computer processing requires data, which is a collection of raw facts, figures, and symbols such as numbers, words, images, video, and sound given to the computer during the input phase.
Data is a raw and organized facts that need to be processed. Data can be something simple and seemingly random and useless until it is organized. Data comes from a singular Latin word datum, which originally meant something given. Data can be defined as a representation of facts, concepts, or instructions in a formalized manner which should be suitable for communication, interpretation, or processing by human or electronic machine. Data is represented with the help of characters like alphabets, digits, or special characters. When data is processed, organized, structured, or presented into a given context so as to make it useful, it is called information. Information is organized or classified data which has some meaningful values for the receiver. Information is the processed data on which decisions and actions are based. It is also a fundamental information in any propagation of cause and effect within the system. Information is conveyed either as the content of a message or through direct or indirect observation of something. For the decision to be meaningful, the processed data must qualify for the following characteristics. First is timely. Information should be available when required. Second, accuracy. Information should be accurate. Third is completeness. Information should be complete.